Hello, everyone. Welcome to the Java Basics session for today. Just want to make a quick check before we get started. I'm just going to give 5 minutes for other people to join. Can you guys see my screen and can you hear me? Can you just let me know on the channel? If you guys can hear me, can you just let me know? Hopefully you should be able to hear me right now. Awesome. Can you guys see my screen? Is all well? The resolution okay? So we got 3 minutes before the start, so I'm just letting a bit more time for people to join. Fantastic. Thanks, Suna. Yes, Natasha, this will be recorded. This is going to be recorded, absolutely. So I'll be coming back and forth between the coding between the IDE, but I have on the computer another screen where I'm kind of keeping an eye on your questions. So I'll try to go slowly. I will be, unfortunately, it's an only one way. I can only talk, and you guys cannot respond to any of the things I'm saying. So please don't hesitate to ask any questions. I'll try to keep an eye on the feed. Please only write to the Java programming channel. And yeah, and Seku, I think that it might be your speed connection. I think that other people can see my screen fine. So maybe you might want to set your settings, the quality of the broadcast. It might be at 320 or 420p. You might want to crank that up to 720p. You have a quality setting in the YouTube broadcast. You might want to change that. Okay, we are 8 o'clock on the hour. Let me quickly check how many we are. So we got 19 people. That's not too bad. We can get started, I believe. So thanks a lot for joining in. I hope that this session is going to be lasting for 2 hours. I hope that this session will bring you a lot of information in terms of the basics of Java. Now, we've got a lot of content to cover. We've got only, unfortunately, 2 hours. So I appreciate that there will be a lot of information overload. So like I said, I can't hear you, so feel free to keep on asking questions when I'm explaining a concept in the Java programming channel. I'm keeping an eye on it, and I will try my best to come back to you. If something is not clear, I'll try to re-explain it in some other way using maybe another example. But hopefully it should be okay, and you guys will get a better sense and a clear appreciation of the Java fundamentals that will hopefully help you a lot in your Android development. Okay, so fantastic. So let's get started. I'm using IntelliJ, but that is really very similar to Android Studio. Android Studio is basically built on, is you're using the same under the hood framework. It is made by the same company called JetBrains. So you might see some little differences in my IDE, but whatever I can do, pretty much you can do that specifically for Android too. So I'm just going to be focusing right at the time for Java, and we will see about Android later on. Okay, so today we're going to be talking about Java, as you know, and we're going to be going back to the basics and some very, first we're going to talk about object-oriented programming, flesh out some high-level understanding of it, and then we're going to go into the details. So what you can see on my screen right now is it's a very high-level plan of what are the key points that I would like to talk about, and maybe clarify some points that are actually very important for you to be able to efficiently, or at least comfortably be able to develop in Android. Okay, first of all, let's take a step back and forget about classes and abstract classes and interfaces. Okay, let's talk about, from a pure orientation perspective, what is, OOP, basically, object-oriented programming. So regardless of language, so be it C#, Java, C++, or any other OOP language, Smalltalk, for example, also, it doesn't matter. The concepts of OOP remain the same, and we have 4 core tenets of object-oriented programming, which are abstraction, encapsulation, inheritance, and polymorphism. Okay, and I'm going to quickly go through all of these because there's a lot of content to cover, but I really want you to understand what these concepts are, because they are the foundation layer of OOP. Okay, so first of all, even before going into this, let's think about, when we write software, what is it for? And typically, from a linguistic point of view, how can we take a sentence or a requirement in English and transform that into more of a abstraction that a computer can understand, and we can implement that to have it run on a computer? So, for example, let me take an example with a switch, a light switch, okay? We all have light switches in our homes, and a light switch basically can have 2 states, right? And it can be, let's say, on and off, okay? This is a real-world example. We're not even talking about right now software. If we had to write, at some point, as systems evolve, we have now more advanced types of, we have some more advanced types of hardware, for example, that can control, we can have a little box that will control the lights in our homes, which is called home automation. Now, there is software that's built into that box to be able to control, for example, the light bulbs in your flat or in your house, right? So at some point, we have to now change that abstraction of a physical hardware switch into a software link, so that we can actually write some kind of program that will tell the machine, bring it some intelligence to say, when I click the switch on and off, I want to send a command or a message to be able to turn on or off the light from a physical point of view. So the software is going to be living in the abstract realm, and we try our best that when we're writing software to use the same kind of abstractions that are coming from the real world, so that we can more easily maintain the code, write it, evolve it, and basically implement the functionality. So in object-oriented programming, we consider that any of the actors, when we're designing some things, are objects. Like everything in Java, apart from primitive base type that we're going to look into, you can consider that everything in Java is an object. Okay. Now, you might have heard a lot that when we were talking about OOP, object-oriented programming, you might have heard that objects, pass messages to other objects. Okay. What is meant by that is actually that when we have, so remember, we went from a physical representation, so we have our light box, right? And we're going now into a software representation that's going to represent our hardware box into an abstract world, which is a software world, okay? So if we had a hardware box here, right, with physical switches, we would like to transform that into a software world, okay? And to be able to do so, we're going to try to model our real world concepts into software concepts, okay? This is where these 4 tenets are going to come into play. Now, like I just said before, objects pass messages to other objects. If you had an object 1, right, and it wanted to ask object 2 to do something, right, it will send it a message. So it'd say object 1 send message to object 2, right? And the way you do that would be within the code, within the class. So we will come to this concept, but I just want to say to you from an abstract, from a very high level, from within, object 1 would call a method, okay, on object 2, meaning that object 1 would some way have within its code somewhere a reference to object 2, right, and call a message, okay? When it will say send a message, what that would mean is that object 2 would actually object 1 here send a message to object 2. Send a message would be equivalent of calling a method on object 2. Okay, so for example, if object 2 had a method called turn on, for example, right, and object 1 wanted object 2 to turn on something, it would say object 2 turn on. The fact of calling this method is what we call message passing, okay? So generally speaking, you will often hear people say just call that method or call this method. From an OOP perspective, we call that message passing, all right? Now, abstraction. Like I said, one of the key tenets of OOP is to abstract. So if we had, for example, a light switch, so we have a hardware box, right? We have a hardware box that controls the light system, okay? The light system in the house. This thing will have an equivalent, if you would have to write an OOP software for this, we will have an abstraction of this that might be some kind of software artifact, which we will eventually call a class when we get to that point. But it will have some kind of software representation, and it might be called hardware box, okay? That's how I'm going to call that. So OOP has one thing, we talk about abstractions. Okay, encapsulation. One of the key things that you'll see that when we try to write OOP code, we try to hide away the internal data, and we try to expose it only by what the methods or the messages. So now I'm going to stop using the word message, but I want you to understand that when you, from your code, for example, call a method on any given object, you're calling a message. You're sending a message to that object, do this, right? So I'm not going to use message anymore. I'm just going to call it method call because it'll be a bit more explicit in terms of code, but that's also how you should be translating it, all right? Now, hardware box that controls the light system. This is our real world right here. This is our real world, okay? Real world, physical world. And we're writing a software hardbox class, for example, or abstraction here, okay? So encapsulation. Encapsulation is about hiding. Encapsulation is about hiding. It's all about hiding the internal state of the object, okay? So whenever you write, for example, a class, you can have an object represented by a class, right? If it has any internal state here, right, you will give access methods, right, to this object to get access methods to internal state, okay? So what does that mean? For example, concrete terms, if you had a class, let's say you have object O and you have a string here, S. So let's say name of object, right? What object orientation tells you about encapsulation is that this object will contain this value, the name of the object that belongs to this object. It's one way of having internal state, but specifically the idea of encapsulation is to say that if object, so let's call this one again, object 3, let's say, for example, object 1, coming back to my previous example, has in its code execution path, it has somehow a reference, it gets a reference somehow to object 3. It should not be able to say name of object. It should not be able to access directly this value. If it needs to access this value, object 3 is the master of its internal state, and it should give some kind of ability to send it a message that someone wants its internal state. So for example, it might, so I'm jumping the gun a bit here, but I know that this basically is slightly covered, so I'm just going to jump the gun here, but I'll go in details later. So if we had some kind of access method here, access method, it would return the value here of name of object, right? So by giving access to this kind of method, what we have done is that we have encapsulated first the behavior, the state, or behavior, I think that's fine too, actually, the state of object 3, and we have provided an access method, okay? So this could be your private method, your protected method, your public method, and we will talk about this also very soon. But this is what your data would be about, okay? And so you would never want any other object to be able to say directly, I want to access the state of this element. That's what encapsulation is about. Inheritance, okay. Because we are modeling the real world, because OOP, object-oriented programming, is all about modeling the real world, if you have two things, things are often be able to be grouped in different categories, right? So for example, if we look at just look at animal world, for example. So we can have cats, we can have a cat, a dog, right, and a fish, right? So you can see that all three of these animals have something in common. And I've just said the word. All of these three, if we talk about these real world representations, through these three creatures have actually a common type in the real world, and we call them animal, right? So in our object orientation, in our software world, when we're trying to represent them, we need to also have a concept of inheritance, meaning that we should also be able to group things that go together. We should belong globally to the same category. So for example, here, when we use the word in English, when we're talking about these living creatures, which are cat, dog, and fish, we would say this is an animal. These are animals. So in that way, we would want to be able to have, and from a software point of view, also the ability to say that cat, dog, and fish are animals, and we should be able to, wherever we are dealing with animals, we should just be able to replace these with one another. As long as our code is concerned, for example, these are all inheriting from a common type, which would be animal here, for example. Okay, so in object orientation, we're trying to represent the real world into our software world. We're trying to take our abstractions inspired from the real world. So a cat, from a linguistic point of view, we have categorized cat, dog, and fish in the same type, which is animal. So if we would have to write some code, we would say, for example, cat is a animal, right? Dog is a animal, right? And you say fish is an animal. Okay? All right. So by writing this, actually, you've seen an interesting thing that's helpful when designing OOP is that if you can replace, when you're saying something, when you're trying to model something from a real world into an abstract form in object-oriented programming, if you can use the word in a sentence is a, you're most likely in a situation where you're talking about a relation between the two elements that is of type inheritance. Okay? So what we have done here is that we have shown that there's a kind of relation between cat, dog, and fish, and they all come from a common parent, which is a parent class. okay, or parent type, or parent category. So a category would be from the real world, and in an object orientation world, it would be type or class, okay? So I hope that is clear up till now. I'm going to make a quick check on the channel just to see if everything is okay. Do you have any questions at this point, or is it very clear, or I can move on forward? Okay, so I don't see anyone typing or any question. I think everything is clear and fine. Okay, great, fantastic. So moving on forward. Cat, dog is an animal. This is our inheritance relation. Fantastic. Last thing, polymorphism. Polymorphism means many forms. That's polymorphism. Other name is equal to many forms, if you break down the word. So what does that mean is that from an OOP point of view, because we're thinking now about categories and types together, we're saying that if at some point I need to use an animal, I can call or use any object or any element object that is also an animal. Okay? So from a conceptual point of view, what we're trying to say is that because objects are linked to each other by some form of inheritance, okay, and inheritance, mind you, can have two forms. Inheritance can be done through a class or through an interface. I'm going to come and detail this because it's a very, very important concept. If you don't understand classes and specifically interfaces, you're going to have a hard time with OOP. So the idea of polymorphism is to say that if at some point I need to use an animal, I can call or use any element that is also an animal, as long as it's, I can use any type, any messages that an animal can understand on any object that is also an animal. So for example, if you take the case just before, right, we saw that a cat is an animal, a dog is an animal, and a fish is an animal, right? If my animal can run and sleep, for example, let's say that those are the behaviors that an animal can have, run and sleep. This is our simple world. In that case, what we mean by polymorphism is that we can safely replace and give a cat, a dog, or a fish to any other object that expects an animal, because it will be guaranteed that if this thing is an animal, then at least it can run and sleep. It might be able to do other things that might be possible, but because it is an animal, I know for a fact that it can run and sleep. And that's what polymorphism is, that we can mix and match and swap in and out objects in our code, in our flow. One object can send a message to another object, or method call, right? As long as it knows that it corresponds to a specific type that has some kind of behavior related to it. Okay, this is in a very quick, high-level fashion. These are the 4 pillars of OOP. Okay. So moving forward from this now, let's get into the details of exactly now how Java handles this high-level concept, which remains true across the board. Smalltalk, C#, C++, whatever language has object-oriented programming concepts built into it, it will have these 4 concepts which underpin the OOP, okay, paradigm. So now let's look at Java, how it works. So let's take a quick example here of, I'm going to go through types. So I'm just going to quickly create a class called main, okay? And I'm going to first, now, because we have this under our belt, let's quickly type about how in Java we represent different types of data to represent now internal states. So remember, we touched on one thing, which is encapsulation, right? Encapsulation, what it means also is that objects keep their internal state. We are modeling the real world, and real world had different attributes. For example, if you take a light switch, it has a state. It might be on, it might be off, right? If you take a speaker, like a computer speaker, it can be on, off. It might have a light to say it's on and off. It might have a color, for example. These are all states and attributes of that object, right? So encapsulation, we're talking about the internal state. We try to keep that state confined to the object, okay? How do we represent the state? We have types. Types represent the state of an object. Okay, there are 8 primitive types. Okay, these are non-objects. Okay, so for example, int is a primitive type. Long is a primitive type. It's a number type. Okay, Boolean, true and false, is a primitive type. You have byte, which is also, for example, a primitive type. So we have many of these different types. There are eight of them that represent very non-state types that in which we can store data. Okay, good. This is the primitive types. There are 8 of them in Java. Okay. Now let's talk about the 9th type, if I may say so. The 9th, so we saw 8 primitive types here, okay? And there's the 9th type, which I call the 9th type. In this case, the 9th type is your class, that you declare. Define or declare. Okay, let me have a quick check on the channel to see. 2 hours, yes, absolutely. This is it's a 2-hour-long course. We might go a bit further on, I hope, if we have time, and if you guys have a bit of time, we'll see where we are. Okay, so please let me know if you have any kind of doubts, anything. We're starting to get now into the more complicated stuff. Okay, but hopefully you guys will be able to follow. You guys are doing a fantastic job. Please stay tuned, and don't hesitate to ask me questions if you're at any point you are lost. Okay, so encapsulation, internal state, we have 8 types provided by Java that help us model this internal state, okay? The 9th type, as I call it, so please, I'm calling it 9th type. You might not find this in the literature, but I'm just trying to say that this is the 9th type because the other type that we have in Java is what you define or declare as an abstraction, okay, which is your class. For example, let me create a simple, quick example here to give you some idea. If I'm representing, let's say, a user profile. So I have a user, okay, and this is a user that I am modeling a web, e-commerce website. We have users, right? And those users, for example, could have different attributes. So you might have, let's say, a postcode, right? The user has a postcode. In this case, I might say that the postcode, for example, of my user is I don't know, 2345. Let's say this is the postcode, right? So remember, these are primitive types, okay? And then the 9th type, for example, that you use a lot, for example, is string, right? Now, string is not a type. It's not a primitive type. It's the 9th type that I called, which is a custom class, right? So this is an object, okay? And I can give my user a name, right? And my user would be called Homer, let's say, for example, okay? And this is how I've represented the internal state right now. So my object here, that my abstraction, so this is what it is, right? Abstraction, which I've called the user, represents a real world user, a human being, right? So I'm modeling from the real world into this virtual world of software by an abstraction called user. And he has a state, which I'm representing here. So 2 attributes to the state right now. My user has a postcode and name, okay? And right now I'm encapsulating this. So how am I encapsulating this is that I represent this these 2 attributes, and I'm going to give access to them by creating getters, okay? So now any object that's using the user object who wants to send a message to get the postcode information or the name information can just call get postcode, get name, right? So 8 types, primitive types, and the 9th type is whatever you make. So string is already a built-in type in Java, but nothing could prevent me, for example, to create a class called address, right? And I could specify now that my user also, of course, in the real world, as humans, we live in places, so we have addresses, right? And I could just define here an abstraction that represents an address, right? And I could just say new address, for example, right? And this would be my address object here that's internally representing the state of my user, okay? And this is also the 9th type I told you, which is it's a custom type that represent. Okay, great. So we've looked at it very quickly. So I appreciate it. I'm trying to cover a lot of ground, so I'm trying to keep momentum here going. We've just got 2 hours, and we've got a lot to cover. But please, any questions at any point, send me a message on the channel. I'm trying to keep an eye on it. So intro to types and primitives, primitive and class. So we've seen that 8 primitive types plus a 9 type is whatever class you make. Fantastic. Now, from this point on, let's talk about modifiers, and this will be it for the very basic stuff. And we're going to get into the classes, the different abstract, inner, static, anonymous, local interfaces, and all of that. Okay. Now, just before I move on quickly, I just wanted to touch on the user again quickly to say that int the 8 primitive types, just for you to know, park this in your information. The primitive types live on the stack. Okay, so your memory, when a Java virtual machine runs, and this is also true for an Android application, when it runs in your phone, there's a specific amount of memory that is allocated to your application. Okay, when a variable like this is declared in a class, and specifically in a method, when it's called, each method has a copy of it in a place called a stack. So primitive types, 8 primitive types are declared and stored in the stack. Okay, in the stack, in your anywhere in your computer or your phone, same thing. This type, the 9th type, is stored on the heap. Okay, you must have heard about the heap and the stack. Potentially, it's stored on the heap. This is where, for example, when garbage collection happens, all the objects that get cleaned up, your application, when it starts to consume memory, your objects are discarded when they're not used anymore. These objects, every time you do a new address, for example, to create an object, well, it is put into a heap. Okay, so this is just for you as a high level to understand like where objects or primitive types live when you declare an object. Okay, now moving forward. Now, one last thing before I move forward, we were talking about encapsulation. So this encapsulation would not be true if I also told you how to control the internal state. Okay, so I'm just going to quickly, someone is having a technical issue I'm on the YouTube site, but can't access the live chat. Am I the only one? Mario, if you are also on the live stream, all chat is done in the channel, in the Slack channel. It's not done on the stream. Okay, I'm not even looking at the stream right now. I'm hoping no one's like posting messages on here somewhere, but just hoping that no one. I don't think so, but just don't post any messages there. Okay. All right. So one last thing before the okay, so one of the key things here is postcode, get name are my accessors to be able to access the internal state of my class. Now, one thing to note, right, is we have modifiers. Okay. Now, further to just quickly review again the idea of encapsulation, right? The whole idea, as I said to you earlier, is that we do not want objects should control their own internal state. They should not give access to their internal state so that any other object can curb their state. So the control, for example, here in my object, I'm giving control to anyone calling an instance. So an object that has been created by this type, okay, that represents an object that has been created in the virtual world that represents the real world. So a user that I've modeled. I want to only give access to other parts of my software or other objects calling this object here to its internal state by these 2 methods, right? To further reinforce that no one can come and change the internal state without the methods, okay, methods that I have provided. There are access modifiers that exist. So for example, there are 4 access modifiers that exist in Java, which are nothing at all, okay, which is called the friendly modifier when you don't put anything. You have the most restrictive one, which is called private, okay. You have the less restrictive one, which is protected, right? And you have the other one, which is public, which means anyone can access, right? So one of the key points here is that by default, you should have a habit in everything private, okay? unless there's a very compelling reason, and we will just touch on some of the reasons why you might not have it private, but something else. Your internal state should always be private. The reason why is if you do this, no one could say, for example, could create an instance of your user object, right? For example, like here, and then say user.postcode. Okay? For example, I don't know, 456, and I could just override. I could not do this if I have put private. And that's exactly, you should be controlling your state. You should not let anything, any other object come and mess with your object by changing its state directly, its state being the fields, the attributes here. So we call these member variables or attributes, if you will. So no one should be able to access. If we put here public, then any code can come, any object can come, get a reference to this object's instance, of this class, which would be an object, and say user.postcode, and he would be able to update it, right? So to be able to further enforce encapsulation, you want to put access modifiers. So there are 4 modifiers. Friendly, when there's nothing at all, it's also called friendly. You have, like I say, private, which you should always declare your mirror. You should always declare your field attributes with private, okay? Or protected, okay? Or the 4th, which is public, okay? Which means that anyone could access this. But public also, you should avoid. Protected, we'll see when you would use that, but prefer always private, okay? Great. Quickly, having a quick check on the channel. All right, and okay, so there's no questions at the time being. That's fantastic. Okay, great. So we'll be able to keep on moving. Now let's talk about classes. Great. Once again, taking a step back. So for the time being, I'm just going to remove all the code that I've written. Doesn't matter. And we're going to talk about classes. Okay. Remember what I said in terms of what our code is, right? We are trying, always remember when you're writing, when you're modeling, you should be thinking about your code. What is it that I'm modeling, right? So when you want to model an element of the real world into your code, right, you're going to represent that with an abstraction, okay? Now, this is where it gets interesting. The crux, we're entering now the crux, which is what? How do you represent an abstraction of the real world? Okay, of the real world. You can create 2 types at a high level, 2 types of abstractions. One that can be created, so one that can be then created and you can act upon it. One that cannot be created, but that just represents as a placeholder, if you will, or just stands as a type with which you can also do interactions, but it does not represent a real type. Okay, it is just a view on an object. So let me give more color because I can appreciate that this might not be clear. Let me show you. 2 types of abstraction. There are 3 types of abstractions in Java, but the 2 core differences: one can be created, one cannot. When you want to create your real world representation, so let's take our example of a user again, right? So human, so real client on a website, right? We're going to model him as a user, let's say. So if I want to be able to create an object of type user and be able to do things like manipulate data on him, I'm going to use a class. I'm going to create a class for user. How do you place a class that represents an object? You say public class user, okay? That's what a class is for. Now, remember, I gave you an example earlier, animals, right? A cat, a dog, and a fish are animals, right? This is how you should look at it. If you don't want anyone to be able to create an animal, right? Let's say you don't want to be able to create, you don't want to give anyone the ability to create a cat, a dog, or a fish, okay? Now, this is going to be a very limiting example, but you just want to have a type that can declare behavior. Okay, I'm going to take the same behavior as I used earlier, run and sleep, that an animal can run and he can sleep, for example, okay? So in the case where you do not want to give the ability to create, but just define behavior, you're going to use an abstract class or interface. Okay? So how does that work? Well, an example of a cat, dog, fish, and animal, you can define, for example, an abstract class, right? Which is an animal, right? By doing this, what you have done is that you've defined a concept of animal, and you're giving it a signature. For example, so you're giving it properties. So you can just say public. Well, you can say public. You can say void run. And you can just say public void sleep. Okay? So the particularity of abstract classes and interfaces is that they cannot be instantiated. Okay? They are a view. You can look at them as a different reflection of the same element, but with different behaviors. Okay? So whenever you want to create an object, you use a type class. But if you don't want to give the ability to anyone to be able to create an object of that type, you use an abstract class or use an interface. Now, there's a big subtlety between an abstract class and an interface, and we're going to see that also. But just understand two high-level types, and we're going to go into the detail of this. But as we go down deeper, I want you to understand the key points here. First point, if you want to create an object that any code can start manipulating and changing state and everything, you just use a simple class. If you just want to create a certain view on that object, right, that has behavior, so you're thinking about the behavior, okay, you are going to create an abstract class or an interface. That does not mean that a class on its own does not have behavior. At the end of the day, you are defining methods in it. The method is equal to behavior. When I say method or messages, now there's a third, synonym for it. You can also replace that with behavior, if you will, okay? So cat, dog, fish are all animals, okay? So we have abstractions. We have a super abstraction that groups these three. So cat, dog, fish are animals, so of type animal, and the animal has behavior. It can run and it can sleep, for example. Okay? Now, let's write some code quickly on this to represent this further. I have my abstract class. Okay? So I'm going to say this is an abstract class. What now this has done is that if I had, for example, keep my main class here, okay? So what I've done here right now is, if in Android Studio, you can press Control J, and it will show you some quick shortcuts for for loops and things like that. So PSVM means public static void main. So we'll just create my main method quickly like that. Control J is a shortcut. Okay, back to our animal example. Let me try to create an animal here. I've created an abstract class. So can I create it? I can go animal, new animal, right? And it will tell me that it cannot allow me to do that. Of public abstract class animal. So if I'm trying to create an animal class, what you saw that it forced me to put these braces here. It did not let me just do this, right? Because I have decided that the type of two types, remember, one, I want to be able to create the object so someone can manipulate it. The other one, I'm just trying to give it another view, another type with behavior that I want to specify, okay? So here, if I just try to create this object animal, it will not allow me because I'm using the abstract or the abstract type. If I just say, I want to be able to represent and create an instance of this concept of the real world of an animal, then if I go back here, I can create my animal, right? Okay. Now, you would say, okay, Amir, but why would you want to do why would you not want to always create an object, right? Why bother, right? Well, there are many reasons to that, many. But let me give you an example. So we've created a type of animal. So like I was saying that, if you come back to our previous example, we said the cat is an animal, the fish is an animal, and the dog is an animal, right? So in the real world, when you're trying to represent something, you're saying, okay, well, even like when we talk about it, you know that if you have a cat at home, right? You have a dog at home, you have a fish at home, right? But all of these three can be grouped in a concept. But what is the most specialized? What is more specialized? So if you're wondering at some point, when should I be using an abstract class? When should I be using a class or an interface? Think about, first of all, the behaviors you want to expose, but also specialization, right? Specialization. What is more specific, an animal or a fish. Well, a fish is definitely more, right? You have a clear idea of what a fish is. It will be in water and it will swim. A dog, is it more specific than animal or not? So if you find yourself in a situation, well, I need to be more specific, well, then that being specific means that if one type is more specific than the other, you have naturally from the real world already know what will be abstract and what will be your concrete class. So I know that animal, right, from our English language, we know that already an animal is just a generalization to put things in, like to categorize things. So I'm going to create a dog here, right? And my dog extends animal. Okay, Amir, what is extends? Remember one of the tenets of OOP, right? We said that these are the 4 tenets of OOP, right? That is very true, M. Kaluzik. It is very true. My fish can't, and we're going to change that. That's very true. The fish can't run. So coming back to the example here, inheritance, right? That was one of the basic concepts. So what is how do you specify inheritance? Later on, I just told you about the concept. Now, how does it work in Java? It's all about using their keyword called extends. So if I come to my dog example from the English translation, I can just say that a dog is an animal. Remember the is a. If my dog is an animal, so dog is extending animal. Okay. If animal is more specific than dog should be abstract and animal should be the class. But this is not the case. The case is that the dog is more specific than animal, right? So most likely in this situation, the dog is concrete and the animal is abstract, right? So always ask yourself, who's more specific? And then that should guide you a bit on how you're going to design. Okay, what will be abstract and what will be not. Okay, great. So we have these 4 types, right? We have our animals, and I'm just going to create the cat and the dog, for example, second, that'll be it. Okay, and animal. Okay, fantastic. So what have we achieved here? So we have tried to we have seen 2 key things, which are the classes concept and the abstract class for the time being. Okay, so we've done the base definition of a class. Okay, I know that some of you were asking me about the initialization block. I'll come to that while I cover this class topic. Okay, we got the animal, we got the dog, extends animal. I hope this is all clear. If I don't see any question, that means I'm crystal clear. Okay, fantastic. Dog extends animal, and I have our cat that extends animal. Polymorphism, let's see this in action. Let's see this quickly in action, right? Let me show you this quickly in action. I'm going to create a dog, and I'm going to create a cat. Okay. And this is going to be my dog, and this is going to be my cat. Okay. Remember what we said in the definition. Polymorphism means many form. Object orientation tells us that through the relation of inheritance, objects can have many forms. This was when I was telling you that you should look at things. If you want to create something, use a class. If you want to represent something with a behavior, have a view on it through an abstract class, for example, or through an interface. But I'll get to that. And I'll be coming back to you guys in multiple ways, using multiple different examples to try to have you guys soak this in. Maybe in one example will talk to you more than another one. That's why I'm going to try to come to you while I'm presenting this with using different approaches. So here we said that a dog is an animal, a cat is an animal, and we have created both of them. So polymorphism says, well, if my objects are extending something a super class, meaning that a super class means that a parent class, okay, well, in that case, I should be able to say that my abstract concept animal is true also for a more specialized, because a dog is an animal, but then an animal is not necessarily a dog, right? So if I create a general type, because my dog is extending animal, I know for a fact that if my animal can void run, right, and run, or my animal can sleep, in that case, because a dog is an animal, it's for sure at this point I know my dog will be able to run and sleep. So by generalizing, okay, I can switch from a specific type. I can use it as a general type, but the inverse is not true, naturally speaking, right? Because this is more general and this is more specific. So in object orientation, you can go from a specific to general, but you cannot go from general, animal is general, to something specific. Okay, I hope this is clear. Actually, it would break. It wouldn't make sense, right? You could not attribute to something very specific something very general. That does not make sense. That's not how OOP works. You have something specific and you apply something very general to it. Okay? Okay. Now, same thing for cat then, right? So a cat is also an animal. It extends animal. So I can just say, cat here. So just to now further illustrate and move onto other concepts, just before we move on, let me create a method in this class, right, that takes in a type, make it run. Okay, that's my message that I want to send, my method call. I want to be able to, and what does it take? It takes an animal type. Okay. So if I write such a method, right, I'm specifying that this method takes this general type. So at this point, I should be able to give it anything. I know that my animal has these two behaviors. It can run, right, and my animal can sleep. Okay, let's take a minute here. One of the things that we're trying to model, right, we're taking the real world and we're trying to bring it into a virtual world of the software world, right? At the end of the day, what do we do in everyday life? We have behaviors. We do things. We do actions, right? We move from here to there. We eat. We sleep, right? So these are behaviors. Object-oriented programming is only also part of it. It's all about modeling behavior. So to be able to model behavior, everything in Java, anything that can create an object or represent an object is actually a behavior. So if you just look at a class, for example, let's come back to our dog class. This dog represents an abstraction of the real world, which is a dog, and it shows also inheritance and some kind of characteristics of this abstraction, showing that it also extends animal. The animal class is showing here behavior, right? It shows a run behavior and a sleep behavior. Okay? Now, a quick check on the channel. No questions. Looks good. All right. So we have the animals here. And coming back to polymorphism, I can just say make it run here. Oh, I'm just going to put this static here for the time being. I'll come back on why static, because this method is static, and what static is, I'll get to that. But let's just bear with me for the time being. So make it run. And I'm going to and you can see that we can call it dog on it, but look, we can also call cat on it, right? And the reason being is that both of them share the same type, and this method, it does not expect the specific type, which is dog or cat. It only specifies I need an animal. And because this animal has behavior, run, sleep, if we added 4 more methods, then there would be 6 behaviors, right, that this would enable to have, and you would be able to call on it. Okay? Now, classes. So we saw, if you want to create a specific type, you use a class object. Okay? If you want to have a view now, so now let me show you this example of what I meant by view, of when you would use an abstract class or an interface. Okay? Now, if I want to add, let's say if I add a new method in dog only, right, which is the following, bark. Okay? You can see that in this method right now, in make it run, I cannot see bark. Why? The reason being is that each class specifies a behavior, like I said previously, right? And classes, abstract classes, and interfaces specify, and specifically abstract classes and interfaces specify behavior. Okay? I will Susiu, eSusiu, I think, I don't know how it's pronounced, but yeah, I'll try to see that. I don't want to get into the thread safety things because it's already complicated, but I'll try to explain I'll try to explain now how things are immutable. I'll try that right now. So just to finish off, interfaces, okay? Run sleep. Now, why can I not see bark is because right now in my code, I've asked for a specific type that represents a certain behavior. Okay, so my behavior right now that is represented by this abstraction has only run and sleep. Okay, so if I wanted to have also bark in here, I would need to also specify this behavior in animal, right? Now, one thing you could do is that you could say, I know exactly what this animal type is, and say, this is a dog, and I could cast this animal more specific type here now, right? So from general, I would go down to specific, just the way from general, we have declared a specific type that we have put to a general type. The runtime here of this, when an object will be passed to this method, right? We know that this concrete type is dog and cat, right? But the view, so I'm saying this from a figurative point of view, right? The view that we have specified here is that of an animal, and whatever its declaration is, its public declaration is, okay? So that view that we have asked, which is represented by a type, okay, but if it helps you, just look at a view. I want the view of an animal only. So here, that's why we cannot call bark. But if we passed in dog here, right, I would be able to call here animal.bark, because these two methods would come from its parent, which represents an animal, but the bark would come from the specific dog view, okay, from the dog type, the dog view, okay? But naturally speaking now, because this is a dog, I've changed the method to expect the dog view. This is not valid anymore because the view of this object, or the type of this object, right, is animal, which is completely different from dog, right? Because in our inheritance model, dog is an animal, and an animal is not a dog, right? So that's why before, if we had put animal here, a dog isn't an animal and a cat isn't an animal, but the inverse is not true. Okay. Now, one key thing. Abstract class, we saw that in an abstract class, we cannot create an object of an abstract class. I cannot do new animal unless I provide some kind of implementation for it. Okay, why would someone want to create an abstract class? Why? Now, the main reason of this is that you want to enforce a certain behavior, but because you'd want to create an abstract class when you want to specify a certain behavior and you want to enforce it, okay? Allow me to explain that. How does that work? Let's say, for example, in our animal class here, example, so we'll continue with our dog and cat and the animal. Let's say, for example, you want to specify the following behavior. Let's say I add a new behavior called eat, okay? But before when the animal eats, I wanted to do the following. I want the animal should make a sound that it's hungry, okay? The animal then eats, then eat, then the animal should sleep, okay? This is what I'm modeling from the real world into our software world. So how would I enforce this? Like, how would I want to make sure that if I am a designer of this animal in my kingdom of virtual kingdom, right, that anyone who in my kingdom would use my API, my animal class, right, anyone would want to create a dog and cat, I would want to enforce that whenever their animal eats, it has to do it by my rules, not by someone else's rules, by my rules. And my rules say the animal should make a sound, then eat, and then the animal should sleep, right? So this is where the abstract class is very handy, because it has a mix of you can implement concrete code, so behavior. Okay, you should always think in your mind, your object, your classes are behaviors, right? So the class can only implement behaviors, right? It cannot implement abstractions. But an abstract class and also an interface only work with abstractions. An interface, sorry, only works with abstractions, and the abstract class actually uses a mix. It can have implementations and abstractions. So here, for example, if someone was using my animal class and I wanted to enforce, because I'm the designer of my world, I'm saying that animals should make a sound, then it should be able to eat, okay? And then the animal should sleep. I want to enforce that. So how would I do that? Well, I could, because I'm an abstract class, I could say public abstract, right? Make sound, okay? So that's what Anescu, no, this is the thing, right? The big difference between an abstract class and an interface, okay, up till Java 8. So before Java 8, this is what I'm saying is true. Java 8 has changed a bit things, but let's keep it simple for the time being. By definition, an abstract class can have implementation. So you can see these two methods, the behaviors that I've implemented, have behaviors, right? This is if I run my code here, if I call run, we would see I'm running, and if I say sleep, we would see I'm sleeping. So these are implementations, right? There is state here. There is state, right? An interface is only about, for the time being, let's look at this. It can have constants, so I would say it has some state, but it only thinks it's a view on behaviors. You are defining a contract, and I'm going to come into this in a bit, okay? So just bear with me 1 second. I'm going to go into even more details. But look at what we're doing, and this look at what we're doing here. I'm defining a method here called make sound, okay? And let's pretend that this method does not return anything. It just makes a sound internally, right? Okay. No, so please don't use the YouTube chat. Use the Slack channel. Please just use the Slack channel. I think I forgot to deactivate maybe the chat channel in the YouTube live stream. Just use the Slack channel for any questions, because I can't keep an eye on the YouTube channel. Okay. So don't use the YouTube chat, folks. Don't use it. I'm not looking at it. Just use the. Okay, so quick question but why don't we use the interface to this concept? I understand that we want to inherit from this abstract class to get polymorphism, but we couldn't use interface to get this implementations. Yes and no. No, that's the thing. You could not. And so if you just bear with me, you'll see exactly what I'm doing here. Okay, so of course, when we implement interface, we need to write this method and something inside it, but I understand why we can't use interfaces. So this is the thing, right? So I'm going to quickly repeat myself here to try to make you guys understand why abstract concept is so important, right? Sure, excluding polymorphism. So just bear with me, follow my example, listen in, and you'll see it will all make sense in a bit. Remember, there are 3 classes, right? One is to create an object. So when I want to create an object, I'm going to use a class type. The 2 others represent behaviors, okay? The abstract class is a mix where I can specify behavior and implementation. But by behavior, I mean methods, like what can be done, okay? So those are just simply put your public methods, the messages that can be passed on and messages that can be called on your object, or methods that can be called on your object. That is your behavior, okay? So for example, what you see on the screen right now, my animal abstract class has 2 behaviors, run and sleep, and the third one, which is eat, okay? But look, now this is the part, right, to your question, Jane, right? Why could you not use an interface? No, you cannot use an interface for what I'm trying to achieve. What I'm trying to achieve is that I am the designer of this world, and my animals, right, when they eat, they have to do the following. They have to do these 3 steps, right? With an interface, you cannot enforce this, right? I want my animal first. He should make a sound. He should always make a sound. Okay? So he should always make a sound. And then he should eat. And then he should sleep. Okay? This I could not enforce in an interface, but with an abstract class, I can. By doing what? I say public abstract void make sound, public abstract void, for example, animal, so specific eat, okay? And then public abstract sleep. Okay, so I don't need, so sleep is already defined, so that's fine. I know how to call it. And look, this is where the big difference now comes compared to an interface, is that now I'm going to say make sound. Then I'm going to call eat, so it's going to be a specific eat, right? And here I'm going to call sleep. Now, what I've done through this eat method, right, I have enforced that now when my dog, so let's look at our dog now. The dog, obviously, because it extends animal, and I have specified behavior that needs to be implemented, right? The abstract, the great word with an abstract class is that you can define, you can have a mix of implementation, and you can also have a mix of just behaviors that need to be provided. So when you want to force something to provide behavior, you're going to say abstract, you're going to add the abstract keyword and say, you need to provide make sound and specific eat. So any animal, anything that wants to be an animal that is an animal, so it's going to extend animal, will have to also specify make sound and specific eat. Okay, so when I look at my dog, if you come back to the dog class now, well, it needs to bark was only part of the dog behavior, right? That is the dog's specific behavior, but it's not the animal's expected behavior, right? So if I want to now add the missing, I'm going to say here, this is a bark. So he might bark here. So I'm going to use my internal representation here, which would be bark, bark, bark. Okay. And specific eat, it just eat, right? And this is going to be a dog specific eat. But now with the power of abstract classes, my animal, so my dog can still eat, and it will inherit the eat method from here. Okay? So let's come to the cat. The same thing for the cat, right? Because the cat is an animal and I am the designer of this world, I have specified that anything that has to be an animal must provide me these make sounds. So the Java virtual machine and the compiler will help me to enforce this relation and characteristics of my class to say, if you are extending an abstract class, well, you cannot instantiate an animal. You have to create your own 9th type. Remember the 9th, that thing I call the 9th type, your own custom class, right? Which would represent your animal, so will extend your animal. And if you're doing that, the JVM and the compiler will enforce you to have make sound and specific eat be implemented. So now, right, if I go into the main, suddenly now, if we come back to our example, I can say run, sleep, and then I can just say eat, right? Because that's the new behavior I've added. But now the eat, right? The great thing now with eat is that I am a specific, I have control now. As a developer, I have control, right? I'm the creator of this world. I have control that whenever eat happens, it will make a sound first, it will then eat, and then it will go to sleep, right? Okay, I'm going to quickly toss in another twist to this before I move on to do a quick comparison with Android to give you a bit more color of what this is exactly. Okay, so quick, I'm just going to throw in something here, a twist. Java gives you the capability to say, okay, I'm inheriting something from an upper class, but I can override it. I can shadow it. I can say, okay, I know that this class expects some kind of behavior by its API. So by API, you can replace, I'm using here in this case synonymously API and behavior. So API is run, sleep, make sound, specific eat, right? And behavior It's the same thing here, right? Okay, so I can add a twist. I can say, okay, well, the person has done this, but I can override. I can override eat because let's try. Oh, I can override it. So the override, what this mechanism gives you in OOP is that I can shadow. So if I create, like in this main type, I've created the concrete dog type. So now the dog, because it's an animal, I know that the animal will eat. But because Java calls methods on the real concrete types, right? It will know at runtime that this animal, so if at this line, right, if I do this, make it run, and give in here dog, here Java, the virtual machine, knows that the concrete type is dog. Even though I'm specifying it with the view or type of animal, I still know that this is a dog. The real runtime of this object is dog. So when I will come here, it will first look and evaluate from the bottom to the top. So the bottom being the more specific class, and then it will go up to its parents, which is the complete opposite route it takes when constructing an object. So I'm going to touch on that also. So here, when I do dog and I say make it run, I can be a bit sneaky here and try to go against my rules of animal class and say, well, my dog can override. Okay, so if I redefine the same method with the same signature, so a signature is this. It's the return type. It's the return type here and the name, and eventually if there were parameters, right? In this case, I don't have any parameters, but that's what it is. So if I override, right? If I override this method, then this is going to be the behavior called. This is going to be my special dog behavior. Okay, my specialized dog behavior. Okay, so this is sneaky, right? And now this person who would be extending my animal class now, the way I've written this, this person has escaped my control. And because I wanted to keep control, I had specified this eat method. It has to make a sound, and then it has to have a specific eat and then do a sleep, right? This person could now do whatever he wants. They could just say just eat, right? They could just say a specific eat, and that would be it, right? And now this has broken my expectation. So how do I counter that, right? How do I counter this? Now, there's a keyword that exists called final, right? Final. If I put a final here, okay, this will prevent now any class that extends animal to override this method, right? So now you can see that by having put final, I'm taking back control. I'm saying to the compiler is telling me now, I'm sorry, you cannot override eat because it's declared final. You have to live with it, right? So that is the way to protect yourself. Now, someone asked, hey, could you explain to me quickly how do you make an immutable class and what makes it thread safe? Okay, so let me give you the good story and then I'll give you the sad story. Okay, so the good story is that to be able to make something that's immutable, there are many ways to do this. And if I take the example of immutable, so immutable class, what it means technically is that once an object is created, right, it cannot be modified anymore, meaning that its internal state cannot be modified anymore. So let me give you an example here. So first of all, we saw that through the modifiers, through the access modifiers, if this dog had a name, let's say, right, and it had an age, let's say, right, these are my attributes. These are my internal state of this object. Okay, so my real world dog representation has a name, has an age, right? If I want to be able to make this object immutable, I cannot create setters. You should not be able to create setters, okay? So you should not declare any setters. You should only be reading. It's a read-only object. Okay, how do we further implement this? By default, if you don't, so we saw that to create an object, you need to have a class, right? And to create a class, to create an object, you need to have a class. And to create a class, well, you just have to define a class structure with some attributes and some getter methods, so encapsulation, right, to access the elements here. So let me give you an example here further. Let me add the getters for the properties of the dog that I just added here. Get name, get age, okay? I haven't added any properties to set this variable, right? You cannot, any object using this code cannot change through any of the methods that it can call on it through. So it cannot send any messages to an instance of the dog object class type, anything that can modify the name or the age. Okay, so we saw the use of final in one example where I made this in the final keyword here to say that this method cannot be overridden. I'm going to use the final keyword again, and when it's applied to variables, class attributes, so class fields or class attributes, as you will. What this means is that it will enforce, the compiler and the virtual machine will enforce that now I have to supply a constructor. Understand that if you don't supply a constructor which enables you to construct an object with a specific value or specific state, you can see that by default, Java actually does not enforce you to add a constructor. In this case, what happens is that if you don't add a constructor, what will happen is that Java in the bytecode will automatically add a parameter-less constructor like this for you. You don't see it in your code, but it is in the bytecode. Okay, it is in the bytecode. Okay, so if you add specifically a constructor, right, you are specifying now to the JVM and the compiler that your object needs to be initialized in a certain way. Okay, and so if you use the final word, this is one step towards immutability, because the final word, when it's applied to a class member, it means that later on, if I was in this method, I cannot reassign anything to the name of variable because the compiler won't allow it. It says that final by its meaning means that it's final. You can just set it once at creation time through a constructor. So a constructor is a special method that has the same name as the class, okay? And it helps you to create an object of that type, okay? And it can have as many parameters as you want. That's not a problem. I mean, of course, there's a limit at some point, but that's a very large limit. So you can, for the sake of argument here, we just say that you can add in as many parameters as you want. And when you add final, okay, that enforces it. So if you create a final element, the compiler will enforce you, say, okay, fine, you've created a final element, meaning that only at creation time will a value be able to be assigned to it. And in that case, well, in that case, you have to provide a constructor. So here, by adding two finals here to each of these variables, I've created an object that has string name and an int age, and these values can never now be overridden. Okay, and this without a setter, where I've enforced. So if I wanted to add a set name, for example, right, and I want to override the name, this would not be possible either. So one way to make something immutable, right, is not to provide setters and to specifically make your variables final. Okay, but there's a dark side. This was the good side, but there's a dark side. As you can see, I'm trying to add a setter, but no, it won't work. Why? Because my compiler is helping me, is protecting me by saying final on this word. I will not allow any more changes to the reference to which these variables point to, okay, or the value contained in them. You cannot override them. Only at instantiation time. The dark side, though, is that, are you 100% protected? Absolutely not. There's a concept. I unfortunately don't have the time to go into it. I'll leave this to your appreciation or into your personal time. It is called reflection, okay? So you can see reflection in Java, how to break immutability, okay? So what does reflection do in just a couple of words? Reflection enables you to introspect the structure of a class to see what it contains, okay? And this can be done at runtime. So for example, let me give you a simple example how reflection is working right now in this IDE. When we do this, for example, if I say Control F12 to see what are the structures, what are the private elements, you can see, for example, here, my IDE is showing me age and name here, right? But if you look at the class declaration, these two fields have been declared private. So how can it show this to me, right? And this is through reflection. You have a class has the concept of a class object. So for example, if I go in here, I could say dog, right? Dog.class. I can get the name of it. I can get the canonical name. I could get the methods in it, right? Get methods, etc., right? I could get the fields in it. And this is called, see, I can get all the fields, even if they're private. So this is why I'm saying, if you want to write things immutable, and you should always write them in an immutable manner because they're thread safe. And unfortunately, thread safety, I do not have time, unfortunately. I would love to talk about it. I love concurrency and all of that. But right now, I don't have time for it. But you should use final when you're declaring the attributes of your class. But just know that through reflection, anyone using your code can go and change values nevertheless, right? There is that power in Java under the hood, okay? But if we just forget the reflection part of it, and if we just look at the pure code, then yes, you should not provide any setters. And by also setting your references as final, you are going to be able to create an immutable object whose states once created does not change. So it's very good. It's very easy to be able to reason about such an object, specifically in a multi-threaded environment. Now, one thing, because this is not the full picture, and I have to give you the full picture to the best of my ability. I want you to understand one thing, though. It's very key. If I write, I'm jumping the gun here, unfortunately, because the problem is very hard to stay siloed and just move on progressively. But you must have all seen the list class, for example. And if I let's say create a list of strings here, okay. So let's say if we created a list of strings here, okay, and this would be our list, for example, type, and we created our list, new array list, right? It's very important to understand that when you're using a type container like this, you have not, now your class will not be immutable, because what final does in Java, contrary to other languages, it will just prevent, because everything in Java is passed by value and not passed by reference, okay? It's just the value of the reference. But this is just a detail, but it has its importance. When you pass in the value here of an age when you create the dog object, so if we went in here, right, when we create the dog object, right, and it needs a name now, okay, dog, and it needs an age now, 34, let's say. Well, in this case, it's a very old dog, by the way, but in this case, if I had created, let's say, if I had passed in, let's say, a list type here of string, okay, so let's say I would have passed in a list type of string. I don't know. Let's say the dog has I don't know, lives at different addresses. Let's say, okay, so it has a list of addresses here, and let's say we would pass in here addresses here. So what would happen here is that even though I'm just going to go and change the dog here's declaration, right? And I'm going to say list of string. It's very important to understand this, because otherwise you might have a false sense of security here, but that would be wrong. So this our list. So you might think that, okay, now this list is immutable, but actually nothing could be further from the truth. Final keywords works well. It will prevent you from normal non-container objects to override the reference. So this reference for name and age will not, and the value for age, because it's a primitive, it will not, the values won't change. But for a list, the only thing that is guaranteed is that this list reference will not be overwritten to point at another list. But you can clearly see that this address right here, right? This address, if I pass it into, let's say, another, if I later on here, I've created my dog object, and now I want to add, something in this list, you can see that the reference now that this this dog had of this array list has now this value in it at some point. So the state has changed. The internal state indirectly of the dog has changed, right? So you might be thinking, hey, this was immutable, but actually it's not, right? Because the list itself can change its state, right? So there's a fine line that you need to understand and be careful of between the reference and what actually the data structure that you're using that specifies that specific type, what it represents. Okay, now interfaces. This is a very important concept, so let's move on quickly to that now. So I showed you like abstract class. I hope, Jane, that this makes sense to why this was different compared to an interface, right? Because in an interface, I would have only specified behavior, and here I enforced behavior of a specific behavior type by declaring expected behaviors and then providing also concrete implementation in some others to control exactly how things are being called. So I hope this is clearer now. Now moving on to interfaces, which is a very, very, very important concept. It's a very important concept. Okay, let's take a step back now. Interfaces. So remember, I told you about 3 ways, right? One, if you want to create an object, you use a class. If you want to specify behavior or a view, just look at it from that you have to use an abstract class and an interface. Now, why interface? Now, interfaces are such an important cornerstone of OOP. I would go to the extent and say if you had to boil Java down to the last thing, it would be interfaces. That's how important interfaces are. Let's take a step back. In the real world, remember, we are trying to model the real world into our virtual world, okay? We talk about contracts. We want to talk about, so I told you everything in this real world is pretty much behaviors, right? We walk, we sleep, we get up, we go to school, we go to work, etc., right? Now, as good designers, you should always attach in a very explicit manner behaviors to your objects, okay? It might be overkill for something very simple, like if you're representing an address or a user, but when you're trying to represent more sophisticated things, okay, it's very important for you to introduce a very clear contract, okay, a very clear contract between what is your expected behavior, okay? So, for example, let me show you this. Let me give you an example here. Let's say, for example, that we are, once again, we're coming back to that same example to just remain a bit consistent and to keep on building on what we said previously, to that light switch, okay? So let's say we're a light switch company and we provide different software. We have a home automation system where we want to be able to provide different, we work with different manufacturers who might be working with, different types of bulbs and lighting systems, right? But we as a software company, we have a software that we sell to our users who can install applications on their Android phone or whatever, right? Okay, so we want to be able to give a home automation system, and we have this concept of a light box, right? We have a light box that has a certain behavior, okay? So if we forget Java for a time being and we just look at OOP, from a design point of view, I have a light box, right? And what can my light box do? So my light box can turn on the lights, turn on. So it's a light box, so it's implicit that it's light. So turn on. It can turn off the lights, right? And let's say it can program the light. Okay, it can also program the light. Let's say. Okay, so right now, when you're thinking about behavior, so when you're modeling from the real world into your virtual world, in your software world, you're thinking about behavior. I'm trying to bring my real world concepts into my software, and I'm trying to look at how do they interact with each other? What can they offer each other? Okay. So I have a light box, and my light box can turn on and can turn off, and it can program. Okay. Now, when you're designing, you want to be as much as possible, you want to have a clear demarcation between your implementation. Okay. You want to separate your implementation from what the behavior that is being exposed, right? So as a company, we're making this light box, and we're saying that our light box in its version 1.0 can turn on, turn off the lights, and can program the lights, okay? So we work with 2 different manufacturers, right? And this is where it's even more important to have a clear contract, because one of the contractor works with the halo lights. Okay. Okay, there's a question that has say, so if I have some class that will always do something, should I write interface to this class? So I'm coming to it, right? So that something is going to be your concrete implementation, but bear with me 1 second, and your question will be answered indirectly. So in our example here, I would say that we're a light box company. We have a box. We're creating turn on, turn off program and a program behavior. That's what we are expecting it, right? And we're working with 2 manufacturers that give us ability, right? Who provide us different functionality depending on what kind of equipment people have in their homes. Okay, so one of the companies has a halo light box, right? And it uses halogen, right? It has used halogen lamps, let's say, and this is a halogen light box, right? And another one just, and we say to them, look, it would be a mess if you each implemented. So let's say that at first we were not very savvy, and we asked them both, okay, could you please give us, we have a light box, and it should be able to turn on the lights, should be able to turn off the lights, and our users should be able to program lights. Okay, and so we just said this to them, right? And both manufacturers came around with this functionality, right? But this is what they did. One of them called on off program, right? And another one, right, was, so let's say this person was in England, right? And another one was, for example, in France, right? And then they didn't realize, but they might have called it their on allumé, right? And they might have called turn off éteindre, for example, and the other one was programmé, right? Now what happened here? Because we didn't specify a clear contract, a clear behavior, right, to these 2 companies, which are our suppliers. So when we got their implementation, right, and we tried to plug it into our box, well, now our code broke, because when we were working off, well, now in our code, if one of our clients bought the halogen kind of equipment, our code will have to call on and off methods and program, right? But when we would be using the other one, we would have to call allumer, éteindre, and then programmer, right? Which would be completely different. So now suddenly our code will have to have if-else statements, and then we would have to check, is this a standard light box, or is this a halogen light box? So this becomes quickly a nightmare, and this starts to go against the rule of OOP, which is polymorphism, basically, right? Which says that things that are common should be grouped together, and we should be indiscriminately able to call, a common, let's say, ancestor or common class, right? So how do we do that? We saw that we had a class concept that enabled to create objects, and an abstract class that enforced certain behavior while still providing a certain level of API, right? Now, how could we just define agreements between clients and servers, right? Between users and service providers, right? So how would that work? That is where interfaces come to play, right? Your interface is it gives you the ability to think about your behaviors. That's all it is. It does not provide implementations. Now, please be aware that now, starting from Java 1.8, I don't think we have gotten an Android there yet, so you shouldn't worry about this. But just for sake of completeness, in Java 8, you can now create interfaces. You can create. You can also provide implementations to your methods through the use of a default keyword that will provide you default method implementations for some methods in your interface. I don't want to go there, so we'll pretend that we haven't reached 1.8. So up till pre 1.8 in Java, your interface can only have behavior. You can only have, method signatures that are behaviors. Okay, it's a view on a certain type of behavior. Okay, let me put this in action to give you a bit more color and perspective. Okay, now if we come back to our good old animals again, we could say that I just want to make sure that a certain level of behavior is applied to my animals. Okay, so now further on to Jane's question, as I could have just replaced this with an interface rather than an abstract class. You could argue that an abstract class has both. It also has a concept of where you're specifying behaviors that should be provided, and is also providing concrete behaviors, okay, which will be called by any class extending the abstract class. Now, to take this a step further, we could say, well, we are going to keep the abstract class, right? And we're going to now introduce the concept of an interface, because I want to make sure of an important factor, that I want to be able to make sure that my animal, for example, is alive, right? So we have an animal, but we could also create a vegetable, for example, right? Which would be something completely different, okay? Which would have completely different attributes. But at a very high level, we would want to have a concept, some kind of element that would bring us back together. So that would be, for example, like in this case, if we had another class called, vegetable, then vegetable and animal might have one common concept, right? Which would be is alive, or is fresh, or whatever, right? So if I wanted to further just focus on specific partial behaviors that I want to be able to expose, right? I could introduce another, interface to say, I just want to check if this, animal, for example, is alive. So I could just, for example, let's say implement an interface called state. Okay, so I would create this interface here called state, and the sole purpose of this would be to say that this interface should be able to tell me if this element or whatever is implementing this is alive or not, right? Now, when an abstract class implements a state, it's not mandatory for it to also provide the implementation, because it's an abstract class, it cannot be instantiated. So we know that the compiler knows that because I cannot create a concrete animal type, I can only create a subtype of animal. I don't have to enforce that the person who's an abstract class that's implementing the state has to provide the implementation. But now if we jump to the concrete types of dog and cat, they will have to provide this interface, right? And then here, but now why would you want to do that? The reason why you would want to now use an interface is that you're not thinking about implementation anymore. Remember the example of our OOP is that as a company, what we would have then said to both companies, look, this will not work if all of you are using different method names, because we cannot use them in a generic manner or reuse them in our code, independently, because we just have a light box. We don't care if it's halogen light box or standard light box. We're just interested to be able to turn on and off. So all of you guys are going to use now this interface called Lightbox. We are declaring a contract, okay? So now going forward, both of these providers now, right, would implement, right, Lightbox interface. So we are providing them the interface, and now they have to, both of them now use, right, this interface. So we're not interested, remember in this case, we were not interested by their implementation. Same goes for in this case, right? My main does not care how it's alive. How do I measure if how an animal is alive and how a vegetable is alive, right? So when you don't want to control the implementation, but you want to ensure the contract that method will be available, but each implementation will provide its own specifics of how that will be done. So when you just want to focus on the behavior, but not on how it is done, that is where you have to work with interfaces. You declare contracts always, right? So that you can swap in and out different behaviors and without having ripple effects in your code, okay? Let me give you another example here. We're going to move away from these cat dog examples, and I'm going to give you a very more concrete Java example that you might have used in your code, right? So for example, let's say in your code or one of your activities, you've created a list, right? And it's a list of string, okay? And this list of string, for example, is a list of names, new array list, for example, right? And these names, you're adding stuff, okay? So because you're using the list interface, you're adding variables. So you're saying A, then your B, etc., okay? Now suddenly, let's say your requirement changes, right? If you had done this, if you, rather than working with the abstraction that is working on a contract or a view, right, where you're defined a clean differentiation between your list, which is the behavior, and your real implementation that provides that behavior, if you're in your code where using this, then you would be stuck. Because if suddenly now, rather than using array list, you realize that you do not want an array list, you want a linked list because you want to go through the elements in a different manner, right? You don't want to use, then you would be stuck. You can see in this code right now, my linked list cannot be applied anymore to an array list, right? And now this would have a ripple effect throughout your code base, because now everywhere you would have to go and change your array list to a linked list, and that would be a catastrophe, right? It might just take you hours and hours. But rather than thinking about concrete implementations, if you're thinking about contracts, right? So just in our example, if you were thinking about the Lightbox interface and you didn't care about if it was a halogen or a standard Lightbox, right? Same way in here, if you were just thinking about always list, but you never care if it was an array list, you just know that it's a list, in that case, you could swap your code through a linked list, or an array list or whatever kind of list, and you would be happy to change implementation as you will, right? So for example, you could have used then an array linked list, you could use an array list, you could use an array list wrapper, etc., or an array queue, right? So that's why when you're using interfaces, when you're writing code, always try to say, what is the behavior of this? And if it's a simple behavior, you might not need to, make your object implement an interface. But if you start writing code that's a bit more sophisticated, then you might want to write, an interface. Now, coming back to a quick example, I told you that, I was controlling my behavior through the abstract class that I had created here, right? I'm enforcing the eat. I want the eat to be done in this order. First a sound, specific eat, and then a sleep, right? So if you look at actually an activity, right, in Android, actually, it's not that different. That's exactly what the app compact activities or the activity is doing for you, right? Because if you look at your app compact activity or your fragment activity, at some point, you will realize that there is an abstract class that is involved, and that abstract class or that class that you're extending is actually making you implement, right? It's making you implement these behaviors. It's making you say, override on create. It's giving that ability without, putting a final there, because somewhere up the hierarchy call, there is a class that is going to call on create, right? It's going to call. So the runtime that's not exposed to us through the Android operating system, but through all of these methods, right? It is the same pattern that is used in the Android activities, so that when you write extends app compact activity or extends activity, the concept is exactly the same. That's what they want to do. So they provide you hooks, right, in your class. These are all the methods that can be overridden, right? All of these methods, right? On start, restart, on resume, on post resume, all of this, right, can be, all the green logs here can be overridden, so that if you want to plug yourself in somewhere in that life cycle, someone will call these methods, and your class that's extending this activity, it will then provide that concrete implementations, right? This is called the template design pattern. So if you want to look into this, this is a lot being used in Android, template design pattern. Okay, so now let's look at this. We have one other thing I didn't touch on is our inner classes and static inner classes, right? So when would you want to use that? Well, the case is, for example, when you want to do that is when you have a very close relation between a dog and a cat, for example. So let's say if you are creating any kind of relation that only makes sense within an object. So what could that be? Let's take, for example, the dog, right? Versus the cat. The dog might have some kind of internal representation of state, right? Where it can go into, you know, a specific, that represents a specific dog state, right? So the reason why you'd want to create an internal class like dog state is just to organize your code in a more efficient way so that the enclosing class, let's say here, could just create, you know, a dog state object here, right? And be able to then work in a much more object-oriented fashion. But you would create that as a private because a cat or the main should not be able to allowed to be create that object, right? That's one reason of why you would create an inner class, right? Is when you want to group things logically. Let me give you another example that will completely like maybe be more meaningful to you. Let's say, for example, I create a class here that represents a database table, okay? Now, a database table has columns and rows. So in my implementation, I might say, well, you know, I'm creating these tables. Maybe it could be good that I create these, you know, this table, but within, I might be able to add a concept of a column, right? Sort of a column class, because my table has columns, and I would also want to add a concept of a row class because my table has rows, right? And by doing this, it might be a bit better. It might be easier for me. So if I'm using like an int here to say the index of the row, for example, right, of the row, and then I might have the same way my index of the column. So I might have other attributes. So then afterwards, when someone is going to create my table object, well, internally, if someone wanted to add, let's say, maybe a row in my class, sorry, in my table objects, let's say add, some kind of row, let's say a string, a value, like, so there would be a name and, I don't know, age. Let's say my table has, a name and an age. Well, I could very easily internally just create this object, new row, right? For example, like this, and then I could do whatever with it. I could just maybe, create, I would have an internal representation of my table as a map, for example. So as a list, for example, for argument's sake, of rows here, okay? And then I would just say, list and rows, for example, right? And I would create a constructor to construct my initial state here. So I wouldn't be expecting, I could just ask, now depending on my situation, what I want to do, I could maybe get externally, I could just say new array list, for example, here, right? And then I could just add things to it, right? I could just say rows, add, and then I could just say, row. So the reason I would do this like that is that I want to organize my code, structure it in a more logical manner, right? But I would make them private because I don't want them to be exposed. So this is another way how you could create inner classes also, okay, without a need. So this is perfectly valid. Now, in some cases, you might want to create a static class. So let's say private, public, static, and this would be the database class, public static database here, okay? Now, so how does this work exactly? Like, how would the static class work, and then how does the inner class differentiate? Well, the big difference here, yes, you will be able to review this all in replay on a video in the recording, absolutely. What about creating an interface object? Is it used? If yes, for what? So an interface object is not used at all, actually. There is no interface object. Your interface is a view on an object, on a class. So for example, when you have created an animal and I implemented state here, I haven't created a state object. The object is animal that also has a type of state. So it's a linguistic difference, but it's still an important difference, right? It's a view that you have on the animal object that is also a state. So depending on how you want to look at it, you're going to use or the animal type or the state type. If in somewhere you want to look at your animal object with a very reduced behavior API, and you want to say, look, I'm not interested by an animal, the API of the animal, so sleep, make sound, specific eat or eat. In my specific part of the code, I just want to know what state. Like if I'm concerned by states. So in that case, you're going to be using that contract, which is state, right? So you shouldn't be thinking about creating an interface object. The interface, you should always look at it by using the implements word. You have to use the word implements when you're using an interface and extends when you're extending a class. So when you're looking at an interface, you should be thinking about what is the extra behavior I want to add to my class. Because in Java, you do not have multiple inheritance, right? You cannot do extends, you cannot say extends class 1 and then class 2. This would not, let's say class 1 and class 2 existed, you cannot do that. Because in C++ you can do that, but it has a lot of problems of conflicts. A lot of conflicts can occur. So the designers of the language said you can only extend one class. One class can only have one direct parent from which it inherits everything. And the workaround to have multiple inheritance, so in this case, in Java, was interfaces. So interfaces is the means by which Java gives you multiple inheritance. But you should look at the inheritance. I could, to a certain extent, if this makes it clear, you can say to enable an object in Java to have multiple behavior, you implement multiple interfaces. If you just want to have, let's say, one behavior, you might just implement one interface, or you might just not choose to implement an interface. You might just extend a class. So this is what we did in this example. Our dog, for the time being in our model, just extended, the animal class. So it got the animal behavior, right, by extending the animal class, and it inherited all of this. So it inherited 1, 2, and 3 behaviors, concrete behaviors, and it had to implement 2 specific behaviors, that was requested by the animal type. But if we had just declared animal as an interface, that would have been valid too. But then we would not be looking to enforce anything. We would just want to enforce that there is some kind of contract, again, or behavior that the dog must also have, right? So I hope that, Jane, that answers your question. So coming back to the static, inner class, basically the idea is to say, in some cases, I want to be able to show there's an internal relation between the containing class here, table, and database, but I still want to be able to give my users the ability to be able to create an instance of database without having to use the outer class, instance. So let me give you a concrete example here to make. Let's forget about more complex stuff. Let's just call classes in a very simple manner. Let's say I create a class called A, and I create a public class called B, right? So this is the outer class. So let me just rename this. Maybe this would be, the outer class, and this is the inner class here. Okay, so this is the inner class. Now, depending on what you want to do, once again, inner classes enable just, or in this case, inner classes here. An inner class enables just you to group logically elements together. So like I was showing to you earlier, the table, it makes sense to have a concept of column and rows together because these are tightly coupled concepts. The table has column and rows, and you might want to design your class like that. Now, in some cases, while you're doing that, my table class in this example, you do not want to enable users to be able to create directly themselves a column or row object. Only the table class should be able to do that. In that case, you create a private inner class. But in some cases, you want to be able to, let's say, create a class where you want to be able to give the ability to the user to also create the inner class while still having the ability, but still maintaining this kind of relationship so that a developer looking at your API can understand, well, this inner class, is related to this outer class in some way because this class is within this outer class. So there is some kind of symbiotic relation between both of them, but it's still okay to create this object. But if I create this object, it will be in the context of this outer type. So if I wanted to create this inner outer object, so I would create an outer class like this, and then I would create the inner class like this. So I would say outer class mu and inner class. So see that the big difference here is that in the first case, when our classes are private, well, they can only be used by the containing class, and they're not visible because of this access modifier that I had showed you earlier, that private just contains everything into that class and does not allow anything to be visible from outside. But when you look at, so that's one thing, but if you're using a public inner class, so you're trying to convey a different message to say, well, I want to be able to create also the inner class. It might make sense in the application we're making, but there's a tight relation here, meaning that you first have to provide me the outer class, and it's through the instance of that outer class can you create that inner class type. Because once again, there's this tight relation between inner and outer class. In some cases now, the third case, you might not want to be obliged to have to create an internal instance. In that case, you can create a static class, like open class, right? And in this case, it makes sense maybe in your situation that you do not want to, create every time an outer object first to be able to first then create an internal object, right? You should be able just to say new outer class, open class, and that's it. You should be done with it. You should not have to create an outer class object to be able to create that inner. And why you want to do this is because this implicitly, when you're creating an inner class in this scenario on line 16, well, the inner class right now has a relation. It can access all the elements of the outer class. So this inner class has a link between the outer class. So from a garbage collection point of view, this object will be more tightly bound, and these objects will be maybe have a more lengthy life cycle than really would be required. Whereas if you're just creating directly from a static class, well, then there is no relation between the outer class as per se and the inner static class, because the inner static class cannot access elements that are non-static in this manner. So you would have a much lighter relation, and from a garbage collection point of view, it would be more quicker and efficient. So I use the word static here. So these were the different types of classes that you can create depending on how you want to structure your code. Now I use the word also static. What is static for? Well, static means basically that Java, when it creates an object, for example, so let me just erase all of this to start on a clean state. And let me just go from our existing example. So let's say we're creating a dog object here. Okay, so we're creating a dog here. And when the JVM basically starts to initialize this dog object, basically, right? And so what is it missing? Null. Okay, so let's say it's null. Okay. When the JVM starts to initialize an object, the way that the whole initialization mechanism works is the following. The JVM comes into this class, the main method, which kickstarts the whole Java process. We come into this class called dog. We look at the dog class and we say, okay, the JVM looks at this class and say, this is a class dog. Let's see what it's made of. It realizes that, oh, this class dog actually extends animal. So first, I have to go one step above again to see what this class is about. Now it looks at this class and says, okay, this class doesn't have a constructor, so apparently it is self-sufficient And I can just create now, I can start initializing on the heap an object that will refer to this type, okay, and use this constructor. Now, right now, this is because there were only private final or private internal variables. Now, if this class, abstract class, has a constructor, so let me introduce a constructor here. A simple constructor that just says hello, for example, or I'm an animal, that just prints it. By the sheer fact of having added an explicit, remember that if this constructor does not exist, it will be automatically added in the byte code, okay, in your compile class. But so there's always a default constructor. It's just that it's implicit. If you don't define it, Java just adds it automatically for you. But if you explicitly now add it yourself, the message you're sending to JVM now, if you come back to the dog class, is that, well, if you have specified this still without a parameter, in that case, you can, it's still fine. It goes, looks at the dog, it says, okay, there's this, class, and it has a constructor, which is equivalent to what was before, a parameterless constructor, so everything is fine. The twist comes now if you add, let's say, the name. So you want to say that the name, animal has to have a name, right? So I'm just going to, add the concept of a name here, and whenever an animal is initialized, instantiated, it needs to be provided a name, right? Now, suddenly, things change. Because a name has been requested by the super class, I mean the class that is a parent of dog, the compiler will enforce this by saying that you have to call the parent constructor first, because the way that the JVM works in the initialization concept is that it first looks at the main type here and walks up the whole hierarchy from bottom to up first without instantiating anything. So there's a walk up, 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 up. Okay, so here from dog, it goes up. It says, oh, you're extending an animal. Fine, I'm going up again. It says, okay, animal, so you need a name. So now it looks, has the constructor of this object called super, which is the keyword to say the constructor. Okay, so if my constructor above had age also, then I would just add the age also here. But right now, the animal class just has one constructor with one parameter, which is name. So the JVM, how it initializes the object, it goes up and it says, okay, now give me the name. I'm going to go one step up. And now on the heap, it creates first an animal representation first, right? It instantiates the name, the string variable here, name, puts a value to it, creates a space in the heap for this object that will be of type dog, but that will also have these multiple interfaces or views, if you will, indirectly, which will contain behaviors, right? So now I will create this object dog. First, it will set this value, this string variable name to its value. It will see that this is the only initialization that was required. That is fine. Then it will come back to dog and say, okay, now I'm going to instantiate the name in this class, and then age, and then our list, and then my object is ready. Okay? Now, the twist with static. What happens with static? Well, static is a special keyword that means that anything that has been declared static, for example, row number, let's say, this static means that this value is actually shared among all of the dogs that are going to be created by this class, right? It's a value, so that's going to be shared. So if we created here another dog here called dog2, right? Dog1 here, dog and dog2 here would share the same static value. So if one would change it, the other would see it also, right? So it's like a global variable. And from an initialization perspective, if animal here would also have a static, let's say static int, let's call it some number, okay? What will happen from an initialization point of view is that the JVM guarantees, so this is a guarantee by the JVM, that first it will walk up from the initialization point all up the hierarchy instantiating and initializing, rather, sorry, not instantiating, but initializing all of the fields that are first declared static. So it will initialize, it won't initialize this. It will first go up again, first all the way up, and say, okay, you're static. I'm going to initialize you. So by default, if no number is provided, the JVM says that by default, all the numbers are instantiated to 0. So even if though we're not specifying it explicitly, this is completely contrary to C or C++, for example, but the JVM, because it runs in a virtual machine, it can enforce some behavior. And one of the clean behavior here is that it will automatically put this number set to 1, for example. But the key point here is that all the static elements are first going to be initialized. Once all the static elements have been initialized, then and only then we will walk through all of the other fields and do the same walk that I just explained previously. So the static element enables you to have a common value that is shared among all of the instances of a class, one thing, and also has precedence in terms of initialization. One other question that was asked was, there is, in some code, a static initializer block that is used. So something like this, or even something like this. The big difference between these two is, once again, first is the accessor. If something is static, so when creating an object of type dog, here we have created 2 instances of type dog, right? So we have created two different dogs in our world here, okay? So in this case, what would happen is the very first time when this class would be loaded by the JVM, if it had an initialization block specified as static, only once, just once, for the very first time when this class was loaded, it would do only once, whoa, it would only once do any action declared in this block, okay? On the other side, this initialization block has the particularity that every time that somewhere in the code a new dog is created, then it would automatically run, code is run for every object instantiation. Okay. So every time that new dog would be called, just before the constructor is run, whatever code you have here would run. Now, obviously, because this is done, of course, we would go into the dog. We would go first in the super. The super would be here. If there would be an instantiation block here, then this instantiation block would first be run. So obviously, there are constraints here. There would be constraints here in terms of what kind of variables and you have access to. Once whatever work that has been done here has been done, then the work here would be done in the constructor. Once that would be done, we would come back to the dog class. Because we would now finish the super call here, we would then do whatever is here. Okay, everything that is here would be done. And then we would do the instantiation of elements here. And then eventually, we would come back here. Okay? So that's how the static, so what static is for, and how, from an instantiation point of view in Java, how it works. And also, when using static, is when you're applying it to a field, a member attribute, that means that it's a shared value that is shared between all elements. But static is also, as we saw, can be defined within for a class, meaning that you want to be able to instantiate that class without having to have necessarily an outer instance first. But there's also another case, a third case where static can be used is directly on methods. So if I wanted to, let's say now, say, you know what, this is not a very cool constructor, it's like maybe too big. Maybe I want to create a more explicit constructor with a more fancy name. I could just say public static create dog only with default name, for example, right? And I would just have to provide, let's say, an age. Well, in this case, what I could do, I could just say public static, okay, dog. So you return me a dog. And I could just say return new dog, for example. And I could just give a default name. So this dog will be called default. And it would just have an age. And, I would just not provide any, let's say, names for it, let's say. And in this scenario now, right, the static keyword is enabling me to be able to create, make a method call make a method call on this class, but without using the new keyword, because this method static is now, I can call it without having an instance of dog and whatever I've done in this. So what I've written here, right? So in this case, now I can create another dog, dog3, and just say dog, create dog with default name, and I just want to give an age, and that's it. And I have a dog. And this is what we call the factory method pattern. It's not the factory pattern. It's just a kind of ordinary pattern, but it's I use it a lot because I don't like spreading across my code base new calls. I rather wrap them into an explicit, clean, method name, and it's static, so I don't have to create a new dog for it. I can just call it directly on the class type, and it'll give me back the required object. The advantage of this over in a constructor, for example, as you can see, the constructor, first you have to put new, and the constructor can only be the name of the class. It cannot be anything explicit. But the advantage of this static approach, for example, is I can give a very meaningful name. I can say create dog with default name. And later on, if I want to create, because the business requires, the requirement calls for it, I can create another static method with another different name that would be very explicit to what I want to do, for example. Okay, so this is, for example, like how you would use now, for example, a static method. So so we saw the access modifiers, we saw the classes, the base definition, initialization block, we saw the abstract, the inner, the static, the anonymous. So we didn't see the anonymous and local, but I don't think at this point is that important. We saw the interfaces. Now let me just quickly touch. So I know that I've just gone beyond 7 minutes. I'm happy to stay long, 20 more minutes, because I want to touch on some other quick things with you guys. So I'm just going to continue. And if you guys want to stay, in, and if you have time, then by all means, just stay in and we can continue. And for those who I can appreciate we are already beyond time, well, I'm sorry about that. But this is recorded, so you can come back to your own time and review the remainder. Okay, but I just want to touch on some other things to give you a bit more information to maybe help you out on some of the things. So enums, right? So enums, you might have seen them. In Android, we try to avoid enums. And the reason why what enums are is just that in Java, you must have seen a lot that in Android specifically, because they're more lightweight, before Java 1.5 and Java 1.2 to 1.4, what we used to say is that often there was a pattern in Java where you would be able to create constants, and people would want to say, okay, you know what, we are creating all of these constants. So like, for example, if I went into my dog class here, once again, we might want to create something, static. So we would say private static final, string, and string, and say this. So this is my constant. And in Java naming convention, some value, let's say. So this is string, some value. So then in the Java naming convention, we always put constants in uppercase like this, okay? But at some point, this was becoming a bit cumbersome, and then we just decided, so Java, the creator of the Java language designers introduced a concept of enums, and they said, well, because it would be just more easier to have, rather than people relying on these constants, so people would use to create, basically, they would just create interfaces like these, right, for the sole purpose of just having constants in them, because you can declare constants in interfaces. So they would just say static final string, and then they would say, my const, my const 1, and then they would have, my const 2, for example, and then of course I have to initialize this, otherwise it won't work. So this would be my const 2, for example, and this would be also, my some constant whatever, and then this would be the way like they would just keep on instantiating values, basically, because that was the way that Java, in Java, the way we were doing this, that we were instantiating constants. That way, if this was public, right? Yeah, sure, I appreciate that. It's a bit late, so thanks for viewing, and then please do continue. I'll give a bit more information on this. So this was how they were doing it. So that in our code, for example, the way you could do this now, you could just say, hey, you know what, I need my const 1, for example. So in somewhere in your code where required, you could just say constants, and you can just say, you know, my constant 1, right? So at some point they said like this is not working, right? This is not going to scale, and it's not, there's no really type checking and stuff like that. So they said, look, let's create a proper type for this, and it's called an enum, right? And let's call this now constants this way. Of course, there's already a constant, so I'm going to call this constants enum, right? And rather than having, you know, rather than having these values like these declared like this, I could just, what I would want actually is just, you know, constant 1, constant 2, constant 3, constant 4. So I would just maybe just, rather than saying that, we could just say my const 1 like this, and then my const 2, right? And maybe these values would be sufficient because indirectly these values would have indexes, ordinals to them, because enums are just glorified classes. They're just like regular classes, but they're adding a lot of, giving you a lot of features for free. For example, free, the proper way of serializing, so they will be able to serialize. You get out of the box serialization support with an enum, with proper handling of, you know, not be able to create multiple instances, because by definition every enum is unique. So there's a lot of powerful things. I won't go into the details because there's a lot that could be said on enums. They're the preferred way, for example, to create singletons. So if you want to just create one object in your whole application so that every part of your object can get access to that one reference, it's called the singleton design pattern. There's a lot of religious debates going on if it should be used or not. I'm not going to go into that debate right now, but just know that there's a singleton design pattern that exists, which is sole purpose. So you could look at the context, for example, like a singleton pattern, right? The context, there's a question asked in the channel, like, what about the context? Like, what is the context? Well, in your Java, in your Android application, a context, for example, is this Uber object that automatically given to your application at runtime that has the full information of all the services and everything that runs on your Android phone, right? And it's your gateway to be able to access all of these information. So content providers, you know, and GPS location services, and the awareness about the Wi-Fi and the network signal, and you name it, right? So all of this is done to this, you know, magical object called the context, and potentially, you know, it's just like a singleton. It's like it's one reference over there, and you can always access it. So I don't know the specifics. It has been implemented using a standard singleton pattern as an enum. I won't go in that because I don't know, but the idea is there. So later on in Java 1.5 and onwards, they introduce this enum concept. So if you want to, so going on from Java 1.5 and onwards, the best way to create a singleton is to create an instance of an enum. So for example, here, there can only be one myconst1, and there can be no other. And whenever in your code, you know, the JVM guarantees that this constant will be created the right way. So in this example, for example, I'm just going to push this a little further just to get closure. If this was the value that we were setting it to, ER, right, of this value, so what would be the equivalent of having this old school declaration and porting it over to enums? Well, because like I told you, enums are just, you know, are glorified classes. Well, then you can just declare that instance and say this, just like a constructor, you would say that in the instance, any enum, you know, contained, so any definition of an enum, right, that has been declared. So you create, this is the definition of the enum, constants enum, and there are multiple different values of these constants within constants enum. There's myconst1, myconst2. Because an enum is just a class, you can just, you know, you can just declare a constructor here, because an enum is just a, you know, a glorified class, and then you can just, you know, create a value here, and then you can just create a method here. But now what you're getting a lot more than just with the declaration of an interface. With enums here, you can get, you know, you can have methods and things like that. So that's very powerful. Now in Android, you'll see that in the Android literature, they don't like using enums, and the reason behind this, from what I've understood, is that of course there's an overhead, because this will create an object in memory, this will create an object in memory, whereas when you're using this, you know, these string values like these, most likely a lot of these will be internalized within a string internal pool in the JVM, so it will have a much less overhead and will be lighter. So obviously on a desktop, you know, where resources are much higher than on a phone, so, you know, you might not be thinking too much about this, but on a phone you might. But to be fair, these days now we have high-end phones that have 6 gigs of RAM or even 8 gigs of RAM, and like a computer, like our phones are just like computers now almost. So it's all debatable. So there's no technical, there's no technical issue in as per se. You can use enums. They're much more flexible. They're more type safe than for example, constants like these. But just to know, it's just good for you to know that this exists, and these are the reason why, for example, in Android they use rather still the old school way, because it's maybe less demanding. And if you have thousands and thousands of objects being created and you're reusing enums or creating a lot of them, well, and actually an enum is only unique as a singleton, so you couldn't even create that many. So it's debatable. So I'll leave that to your own appreciation as you learn more on your Java journey. But this is what it is. So generics, right? So as people who are not familiar with Java, let me just quickly also touch on generics, right? Because you must have seen a lot of you must have seen things like this, for example, written like list and string, right? And then you create list of names, for example. So you just call it names, right? And let's say we're creating a list of objects that have names here, and we want to add things to it, right? So you can just say, A, B, and C, for example. So what are these? What is this thing actually, right? So in the early days of Java, up to 1.4, where generics did not exist, you just had what we call here a raw type. So you would just have lists. And even today, if you did this would actually perfectly work, right? The only problem was that back in the day, from a contextual point of view, to understand why they did this, is that when you would add something to it here, if your list is just a raw type like this, well, you could just add even a number in it, right? And you can clearly see where this is going, right? I could just add also null here, for example, or some other value. I could just add true, for example, here, right? And you can see now my list suddenly has a string, has an int, and also has a Boolean. So if I were to iterate over this list now in my code, and I was, naively expecting that my code was well written, and somewhere in the code, everything was, passing through it, passing through it names, was only adding names to it, right? What would happen is that, I would be iterating over, object, and the old school way of doing this was I would just say string. So this is my current string here, string, expected string. I would just cast s, which is object type here, and I would just cast it to string. And you know what would happen here, right? I would run this code right now, and there would be a class cast exception, because as soon as I would go to the second element, an integer, so up till here, this would be fine because an integer is also an object. But when I would cast my integer to a string, it would just blow up, right? So in the good old days, pre 1.5 in Java, this is how we used to code, right? We used to know exactly and look at our code very closely and say, hey, you know what? Just want to make sure that I'm not putting in any other type, because by default, this is called raw type, and raw type accepts object. So in the 1.5, they introduced the concept of generics, was to say that, hey, you know what? Now, no more of this. We're going to add string here, and we're going to clearly specify with the chevrons, what is the exact type of element that should be inserted into this list, in this container. And this now, because of this, now the compiler can early on capture these coding issues. And as you can see, it's telling me, hey, first one's fine, but look, now you're adding an integer, and now you're adding a Boolean. So this is definitely not okay. So now, rather than having bad runtime exceptions, right, where my program might fail in some obscure way, well, now I have all of this being captured, during compile time, which is much more safe, which is safer. So, which is much better. So generics were introduced now just for the sake of, a bit of more clarity. And it's interesting to know that once your code is compiled, if you would look at your bytecode, actually this whole string information is gone, and we're back in the bytecode. We're back to this. But this works. The reason why is because at the compile time, your code has already been checked. It has already been, the compiler, as you can see, has already made sure that you were not casting to any kind of obscure type where things would not work. The added benefit here is that I could also now use string. I don't have to use object because I am specifying this as compile time. Obviously, at runtime, the code becomes the following, right? There is no more concept of string here. Everything is an object, right? My cast, I have to do my cast here, and the code will be doing the cast. It's just that it's syntactic sugar for the developer, but that increases code safety. And the whole action of having this in the code, and when you compile the code, for it to disappear like this, it's something called type erasure. So you can look at this up in your own personal time too, for those who are more curious and want to know about this a bit more in detail. Okay. Now, I quickly touched on enums and generics pretty much. We touched on the super word for object instantiation. We looked on static. We looked on final. So one last thing I just want to tell you about final is also, like, if you don't want anyone, so if I was creating in my world here and I didn't want so let me not touch animal, but let me say that I further do not want any class to extend dog. And let's say in this virtual world that I'm creating, you can only have a dog. You cannot have a special, like a bulldog or an Alsatian, for example. I don't want any further specialization. So I can also add the final at this level, for example. And at that level, the final prevents any more classes to extend this class, meaning dog. So dog will not be able to be extended anymore. So that's one other use for the final keyword, for example. Now, one other thing that I cannot let you guys go without knowing this. I'm sorry I'm pushing this a bit further now, but this is important. So I was hoping that it would not take such a long time, but I really need to touch on this because this is going to be important for your Android development. So let me talk about these three quick data structures, but I'm sure you've used these data structures, but that's not what's important. What is important is the equals and hash code contract, which you might not be fully aware of. So I wanted to really touch on this before we part. So let me quickly also kind of put in some more details for you on this. So we're going to continue with our good old animals here. And let me say, for example, let's say that this is our code running here, and we have let's say we're creating a map, let's say. Okay, so let's say we're creating a set. Now, a set, for example, has the particularity of only containing unique elements in it. Okay, so you can only have one object certain type. Okay, so for example, if I create a dog here, if we had dog. Okay, so I'm just going to simplify the constructor here for a while because I just don't want to maybe just going to create a default constructor here, so that's going to be easier. So new dog. Okay, I'm going to create a cat here. Yeah, new cat. Okay. Animals, you can add dog. You can add cat. Okay, for animals. Cool. We just added a cat and a dog, which is fine. But what if I added another dog? Let's say if I created another dog 2 here, right? How would it differentiate between dog 1 and dog 2? A set by definition cannot have duplicates, right? As it stands right now, if I ran this code, I would just because I haven't specified anything. Well, actually, let's run this, right? So let's say animals size, right? So let's see how many count of elements do we have in here, right? So source release requires. So let me do this here. Hey, I know, Jane. I would have loved to touch on it, but I just realized, man, there's so much to talk about and to be able to explain this. Hopefully, let me see if I can, organize another session like this, and I'll just talk about patterns. soon on this. Would that work? Would that make you happy if we did that? What is this happening here? Completed with one warning and error. Java test source release requires target release. So what is this? Don't I have a target release here of 1.8? Target, this is language level 8. Oh, okay, so maybe this is the compiler here. Yeah, there we go, right here, bytecode 1.8, there you go. So if I just ran this here, okay, so I need to just create the matching constructor, which is fine. What else does it want? String name, okay, cat, there you go. Here you can see that it actually added in a unique manner the different dogs. So even though I created 2 different dogs here, what is happening is that I'm inheriting the default values from the object class of equals and hash code. So if you go all the way up in the call chain, basically, I'll go all the way up to the object class, basically, from which all Java objects, inherit from, which is this class. And in this class, you will see that there is the equals and default. There's a default implementation of equals and hash code, and all the objects are basically inheriting it from there, from this equals here and hash code. Now, this is a very important relation because whenever you are specifying your own class and you want to be able to uniquely identify it as a duplicate or not, for example. So I would argue, as actually in this example, because I've created the same dog, as you can see here, what would have been the correct behavior for a set is only 2 here. There shouldn't have been 2. There shouldn't have been 3 elements here because I just created the dog with the default name. So technically in my set, I should have only 1 dog, the default dog, right? I shouldn't have been able to add a second default dog. That doesn't make sense. So the way to do this is when you have to override the equals and hash code method. So you override equals like this. And when you override equals, you override also, it's mandatory for this to work correctly. So anything that has to do with a hash, so hash set, hash map, anything that is relying on hashing, which is pretty much a lot of data structures in Java and in Android, is that you need to override the equals and hash code method. And your equals, this is where you specify how does equality work from your business object, right? So for a dog, maybe 2 dogs are equal if and only if, for example, if this name equals the name of the object that I'm comparing it to. So I would get name here. So this would be, so here I would say, I'm not writing the fully blown version of the equals, but I'm just saying I'm just casting this object to dog because that's what I'm expecting. So I would say if my current instance, which is this name here, equals the other object that I'm comparing it to, other is equal to name, and this age is equal to other dot age. If this is true, then this is my equality. 2 dogs can only be the same if they have the same name and the age, okay? And when I'm using hash code, what's important here is that whatever field that I've used in my equal comparison, I have to use its numerical representation. I won't go into the detail of this because it might have a whole dedicated discussion just on this topic because that it can go very deep. But just know that you can just say hash code plus, for example, this age dot just age, because it's hash code is just an int. So you're just adding the ints of these objects. So this is how equality would work. So if we come back to this example and we run it again, our example, And we can see that we just have 2 elements and not 3 anymore, is because now we have specified what is the equality relation, right? We have said to, by overriding equals in hash code, we have specified now in our class how do so when using a hash set, so anything that has a hash map, so link hash map, hash set, basically anything that has hash in it, it's built on this very important concept of equals and hash code. And you need to really understand this. Otherwise, you'll have a lot of problems even in your Android code, where you might be adding things in a list, for example, for your adapter, and you're adding that to your adapter, and you might be seeing duplicates and things like that. So you need to really specify what is your relation, what is your unicity relation, what makes an object unique in your business case. And of course, it's going to vary from application to application. And in this case, for example, that we illustrated here, a dog is unique if it has the same name and age. So if we run through the logic of the code, we've created our hash set. We add a dog. The first dog is fine. The hash set is empty. Okay. Then we add another dog, and it says, okay, I already have a dog in here. Let me compare this dog with every other dog. So for the time being, the first dog got inserted because it was the first one. The second dog comes around and says, okay, let me compare. So if we went into the equals level up to the point where the code calls equals and hash code, and the equals method, it would say, okay, I'm a dog. I'm a set. A hash set by definition only takes in unique elements, and there cannot be any duplicates. It looks at the second dog and says, what's your name? And it compares it to all of the other dogs. In our case, there's only one other dog, and says, okay, are you just one dog? Okay, what's your name? You have the same name as myself. What is the other criteria? Well, it's age. So do you have the same age as myself? Well, you do, because we have used the same method, which is the default initializer. And that's why it says, okay, I already have a dog just like you, so I'm not going to add you, so I just skip it. And then it just adds a cat. Well, obviously a cat. So the equals method, of course, is depending on our implementation. And right now, the cat, because it doesn't have also equals and hash code, if I just added another another cat in here, well, then we would be back to a count of 3, because it wouldn't differentiate between the first cat or the second cat, because we don't have any equals or whatever method. We don't have any equality defined in the cat here. So if we just reran, this, we would then have one element here. The second would be skipped because dog does have equality, number 2 and number 3. So if you just rerun this again, we would be back to 3 again, right? And obviously, if we went back into cat here, well, then we would implement equals and hash code. And depending on how we implement it, well, the result will change. So this is the other thing that's very important. And this is actually goes through all of the hash, data structures. So it's very important that you work on, you read this up a bit more in detail. But this is the equals and hash code. That's what it's based on. So it's very important you look into this. Okay, so so we're 2 hours and a half in. The other section I wanted to touch on was the design patterns, and also I wanted to write. I had come up with an idea of writing an application and writing tests with this. So hopefully, unfortunately, we don't have time. I think I'm going to stop it here. But what I'm going to do is that hopefully very soon I'm going to give you guys a bit more time ahead, and we're going to have a second part to this session, and we're going to now go into more details of just the strategy design patterns of how to design your application. And we're going to kickstart the session directly by designing a vending machine software where you can add coins into a machine, and it will deliver you drinks like whatever fizzy drinks that you like to drink. And of course, there will be a price attached to it. And we're going to see all the logic of how we're going to design that. My goal was maybe it was a bit ambitious. I was hoping that I would be able to go faster on this, but then it took a bit more time to kind of clearly explain these concepts. I hope there was a bit more clarity provided to you. I know there was a lot of information given to you. I hope that you came out of this a bit less confused rather than more confused. Otherwise, this was really not the purpose was definitely not achieved, and I really apologize for that. But I hope that I will have time to maybe set up in a second session, and we'll take it from here. Okay. Once again, guys, thanks a lot for tuning in. It was great having you guys, and I hope to see you guys soon again. All right. Bye-bye.